The Notecards project is more than just a system building effort. Rather, it is an effort to understand the nature of the authoring process, especially those aspects of the process that involve managing and structuring the ideas to be communicated. In this project, we face an enormous variety of research issues. In this videotape, we'll discuss 3 of those issues. First, we'll discuss the issue of tailorability. Second, we'll discuss the issues surrounding argumentation. And third, we'll discuss user psychology issues. We'll take each of these up in turn. First, let's consider tailorability. A system such as Notecards is highly sensitive to how well the user interface is designed. However, it is impossible to design an optimal user interface for the wide variety of users that come to the system and for the wide variety of tasks they bring to the system. Therefore, it is necessary for the user himself to be able to tailor the system to his own special requirements. Our approach to tailorability is in 2 steps. The first step involves making all the functionality of the Notecard system accessible to the user through what we call a programmer's interface, so that the user, through simple programming, can tailor the system to his special requirements. The second step is then to make these tailorability operations accessible to the user through non-programming kinds of interactions. Randy Trigg will further discuss our programmer's interface and will demonstrate it for you.
Tailorability can be accomplished by means of the Notecards programmer's interface. This gives users access to the full functionality of Notecards under program control, and at the same time ties Notecards into the powerful Interlisp programming environment. We will look at 2 examples of the programmer's interface in action, but first recall that the authoring process, as we've been viewing it, often includes the act of writing a paper based on an outline. Ken Allen liked to do this by composing text in a large window in the center of the screen surrounded by the relevant note cards. We can enable this style as well as others using the programmer's interface. Here's an outline of a restructured version of Ken's paper. What I've done is to pull apart the text of the paper into cards, 1 for each section. I've also pulled the notes out of the paper into file boxes. This outline card serves to organize these separate cards. For each section, I have a link to a card containing the text for that section, and I have a link to a file box containing the notes relevant for working on that section. Now, suppose I want to work on section 2. Well, I've written a simple programmer's interface function, which allows me to bring up the entire working context of that section automatically. When I run this function, first thing it wants to know is the card that contains the text I'm working on. The second thing it needs to know is the file box containing the notes. And now it first brings up the card with the section's text, and then it surrounds that window with the cards containing the notes. And now I'm ready to work on my section, and I can refer to the text in these notes as I work on the section's text. We've seen how the programmer's interface can be used to tailor note cards for various styles of screen management. With the programmer's interface, we can not only manipulate existing cards, but create entirely new card types. Now, we've seen some system-defined types such as browser, filebox, and sketch. In our next example, we'll see some new types that were designed using the programmer's interface. Let's consider the domain of legal case analysis being studied by Art Farley. Here, one breaks the textual record of a case into its constituent parts to form a brief. Rather than having to recreate the same linked structure of cards for each case, we can use the programmer's interface to facilitate this process. Here is a portion of text from a contracts casebook on the Boone versus Co. case. What I want to do is to break up this linear text into a brief and integrate the brief into my note file. To do that, I've defined a new note card type called the case cluster, which I can use for standardized legal case analysis. So let me create a fresh instance of the case cluster. And let me give it as title, Boone versus Co. And now what's happening is that rather than simply creating one card, an entire interlinked network of cards is created according to a predefined structural template. Now what you're seeing here is the head cluster card, followed by four of the cards that make up the substructure. Now, what I'd like to do now is to distribute the information from the record into its constituent parts represented by the four elements of the cluster. So let me start at the legal facts. And I'll bring in this first sentence as a legal fact about the plaintiffs. And now let me look for the decision in this case. And I'll find that down here at the bottom of the record. And we'll copy that in. And similarly, I could continue filling in the various portions of the cluster from the case record. Now, what you're seeing is only a part of the structure that was created when this case cluster was created. There's some substructure, and that lives under the rationale card. Now, the rationale consists of arguments that were used in deciding the case. And because these arguments can sometimes have complex structure, we've defined a new card type called the argument card, which is a specialization of a browser that shows this structure. The browser contains links to cards representing the rules and support for those rules. And we could go into there and add text to those cards based on our particular case. So now we've seen how the cluster can be used to analyze our case. And for that purpose, this square array of the four main elements of the cluster is very handy. But we might want it to have other arrangements. And to do that, we have defined various operations that can be done to the cluster. And these are all done through the head cluster card. For example, suppose I've been working for a while, and my cards have been moved around, and perhaps I've closed a couple of them. And I decide now that I want to rearrange my cluster. So I'll move the head cluster card to the place where I want the new arrangement to be, and I can lay out the cards in what we call a cascade, which is a compact grouping. Now, there are other operations that I can do to the cluster as a whole. For example, I can close the cluster, and to do that, all I have to do is close the head cluster card. Thus, we have seen how the programmer's interface can be used to tailor note cards, transforming it from a general-purpose idea processor into a specialized tool, such as we've seen for legal case analysis. Currently, using the programmer's interface requires writing Lisp code that calls a predefined set of functions. Future work will move toward a more descriptive interface, eliminating the programming knowledge currently needed to tailor the system. Toward that end, we are now investigating loops, the object-oriented programming environment developed here at PARC, as a possible vehicle for future versions of note cards.
Next, let's consider the issue of argumentation. Perhaps one of the biggest benefits of using the note card system is the help it can provide in formulating and diagramming arguments to support ideas. Our research into argumentation has two parts. In the first part, we are trying to discover appropriate vocabularies of links with which to build up argument structures. In this effort, we are at first working in highly structured problem domains, such as legal reasoning. In the second part of our work on argumentation, we are trying to discover appropriate reasoning mechanisms to build into the note card system. For example, we are considering a truth maintenance system that would allow users to manage their assumptions and to trace the dependencies among their ideas. One of our users, VanLehn, has found using note cards to be very helpful in developing his own elaborate style of argumentation.
I'm VanLehn, and I'm a cognitive scientist here at PARC. I'm here to tell you a story about how I used note cards over the summer and how it helped me do my work. Now, in order to tell you a little bit about this story, I have to tell you a little bit about what I do. I build theories of how people learn simple procedural skills. Now, that requires postulating mental structures and processes that are quite a bit removed from the observable data. In fact, there are these long chains of argument that go between the data and the mental structures that are postulated. And there's a lot of room for interaction in those long chains of inferences. Consequently, the theory becomes very difficult to document and because of all those theories. In fact, this much paper is needed to document that theory. So when the time came to change the theory this summer, I got some new ideas and some new data. I was left with this problem of untangling all the interactions of the hypotheses and the arguments. Notecards seemed ideal for this. It would at least provide me a cross-index so I could find out what arguments depended on what assumptions and what data supported what hypotheses. So I converted this monster into notecards, and it took me about 10 days solid. And by goodness, I actually managed to find those dependencies and revise the theory. But that's not the story. The story has to do with what happened afterwards. In a nutshell, Notecards allowed me to see the theory in a new way, and I was able to see some improvements to the theory which significantly changed it and made it better. Now, the first change happened when I tried to browse my note file. I had thought that basically I had a set of basic assumptions that would lead, like by a kind of a logical, almost entailment process, out to a bunch of hypotheses. And I thought, well, you know, I'll see this tree with the roots of the tree being the basic assumptions, and then further hypotheses and assumptions following from those, always in empirically motivated arguments as their grounding. Turned out when I browsed my note file, I didn't get any such thing. I got a bunch of fragments. I was missing some major assumptions, and it didn't take long to find out what they were. In fact, there were 6 specific assumptions that I was missing. When I put those in, I in fact did get the tree that I was expecting. I can show that to you here. I've got my tree now with those 6 plugged in. I've double boxed the nodes that represent assumptions that I had forgotten to make, had overlooked making because of the linear structure of text. With those in place, and here's another 2 over here, I was able to complete the argument structure. So completing the argument structure drove me to find assumptions that I'd been tacitly making. Now, what was significant about that was that some of those assumptions were rather weak. One of the assumptions turned out to have such a plausible alternative that I am now in the process of revising the theory to try and see how it will look with that assumption in force. And I think it's going to be a significantly better theory for that. So by using the browser, I was able to cover, in some sense, a set of assumptions that were so big and so overarching that I didn't even know I was making them. And that was one way that Notecards helped me improve this theory. The second way has to do with sort of the fine structure of Notecards. When I converted the arguments in the technical report to Notecards, I used a linear sort of debater style, the same one used in the technical report. I can illustrate that with this kind of card here. This is the old style. There's an issue with several hypotheses, 3 in this case. Each hypothesis has its own card. The arguments for and against, pro and con, the hypothesis are indicated by argument links here, like this is a pro marked by plus, this is a moot argument marked by 0, and a minus sign, a tilde, is used to mark the con arguments. The top level card doesn't have the pro and con things laid out explicitly, so it makes it a little more difficult to see which ones have more evidence. So I changed the format around to use a matrix style, which I can show with this card, which makes it easier to see how many pros and cons each argument has. All the pros and cons are laid out in a big matrix here. The hypotheses label the rows, and the column labels indicate the kinds of evidence that are used in the various arguments. For example, this argument shows that this kind of evidence bears against this hypothesis. Now, this matrix is all filled in, but when I started out just by recoding the arguments from the technical report, I discovered that, in fact, the matrix was not filled in. Only the diagonal elements of the matrix were there. I had overlooked to compare certain kinds of evidence with certain hypotheses. Well, it didn't take too long to fill in the matrix because I already had the evidence, and lo and behold, the hypotheses changed. Some of the ones that seemed like losers now seemed like winners because they had a lot more pro arguments supporting them, and some of the winners now seemed like losers because they had a lot more con arguments against them. Consequently, I began to see that I had overlooked some of the interactions of the evidence and the arguments. And that led me to see that some of the arguments were not as good as I thought, and some of the hypotheses that I thought were winners were actually losers. And so the theory changed just by having this new format for the note cards. And the reason why was I was using a nonlinear format. All that time I'd been using a linear debater's format had allowed me to overlook these interactions, and with this matrix kind of format, it was obvious that something was missing. So note cards, by allowing me to view the theory in a new way, allowed me to see opportunities to improve it. The browser was the same thing. By allowing me to see the theory in a new way, in an overarching way, I could see large arguments that were, in a sense, the forest that I couldn't see through the trees, if you will. That viewpoint allowed me to make significant improvements to the theory.
Finally, let's consider the psychology of the user. Our goal here is to understand the nature of the authoring task from the user's point of view. By discovering the user's critical cognitive processes, we have the best chance of providing facilities that genuinely help the user in the authoring process. Melissa Monty, a graduate psychology student at the University of California at San Diego, has been investigating some of these issues.
In my research, I'm characterizing the tasks that people perform when they use personal information storage systems, such as the Notecard system. I examine these characterizations in detail in terms of the psychology of human memory and organization. I have an example from our videotape data that will illustrate how a system such as Notecards can affect a person's behavior. We will look at our subject Ken, whose NATO missiles note file you saw earlier, as he is filing some notes that he's taken and placed on note cards. He's not yet placed these note cards in the appropriate topic file boxes in his note file, and that's what we'll watch him do. You can see the set of unfiled notes here stored in this special unfiled cards file box. He's familiarizing himself with the contents of some of these cards. It's a well-known problem that a title for a file or a card does not provide enough information for the person to be able to recognize that card when they go to work with it later. This is true even if the person was the one who wrote the contents of the card and selected the title. So he's familiar with the cards now, and he will use his topic browser to access the file box that he wants. He selects the topic box and he places it on his screen and scrolls through the contents of that box to determine that, in fact, he made the correct decision about which box that he wanted to file his card in. He moves the card into that box, but before he puts the box away, he goes back once more to his set of unfiled cards and scrolls through them to see if there's any other card that he might want to move into that box at this time. So let's examine a completely different strategy that another subject in our studies has used for accomplishing almost exactly the same task. This subject has stored thousands of notes on 3x5 file cards in several boxes on his desk, and I've simulated a piece of that here. He takes his small stack of unfiled cards, picks the first card off the stack, and scans his topics to decide where to file it, thumbing through the file if necessary to determine the appropriate place. He places the card in the box and then takes the next card off the top of the stack. If he's not sure where to file this card immediately, or if he thinks perhaps he needs to put in another subtopic in his filing system, he'll set that card aside along with other more difficult cards and deal with it later. It's important to note here that this subject files cards, most of his cards, in from 4 to 9 seconds, which is a fraction of the time that it takes our subject Ken to file cards. So what accounts for this large difference in strategies that these two subjects show? I think it's important to note here that a subject will adapt their strategy to the structure of the system that they're using. When this subject accesses a card, he has all of the information about the card available to him every time he accesses the card, and it's available immediately. And this means that he can recognize the card much more quickly. When our subject Ken accesses a card, his strategy, he prefers to deal with the icons that contain only the titles of the cards. This means that when he uses these titles, he must keep all of the information about the contents of the card available in memory so that the title works as a good retrieval cue for the card. This added memory load means that his decision process about where to file a card is much slower. There's probably two reasons that he prefers to work with the icons. One would be that they take up less space on the screen, and the other, perhaps, that it's much easier for him to manipulate them as objects on the screen. Okay, now psychologists have studied human memory in detail, but most of the studies up to this point have been of small, relatively small numbers of items. When you're dealing with a information storage environment like the note card system or the 3x5 card system or the files and piles of papers and shelves in your office, you're dealing with hundreds or perhaps even thousands of items. And this means that the memory storage and retrieval processes are going to be much more complex. As we collect more information and do more detailed studies about systems such as note cards and related tasks in non-computer environments, we can learn more about what kinds of information people need to accomplish their tasks. This will allow us to design computer interfaces that can help overcome some of the problems that people encounter with the computer displays, such as limited screen space or the fact that there's a fairly homogeneous visual environment. Our interfaces can also help people to adopt strategies that help them to take advantage of the characteristics of human memory.
These are just a few of the many research issues that we are interested in. We view the note card system primarily as a vehicle to help us explore these issues. Although the note card system has already proved to be quite useful, we feel that we have just begun to open up the possibilities of a new generation of computer environments to help people in complex authoring tasks. However, any great leap forward in the design of such systems will strongly depend on our making progress on at least some of these basic research issues.